Let us discuss about binomial theorem. First, let us see binomial theorem for positive integral index. Binomial theorem for positive integral index. If x and a are real numbers, then for all natural numbers n, x plus a whole power n can be expanded as nc naught x power n a power 0 plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a power 2 and so on. Last term will be ncn x power 0 a power n. We can write this as in sigma notation r equal to 0 to n ncr x power n minus r into a power r. This is the expansion for binomial x plus a with positive integral index. Means n is natural number here. Index means power. I think it is very clear for you. Here ncr is nothing but n factorial by n minus r factorial into r factorial. Here n is more than or equals to r and n comma r are any whole numbers. Under these conditions, this will be defined. For example, 7c2, if you want to know, you have to write 7 factorial by 7 minus 2 factorial into 2 factorial. Nothing but 7 factorial by 5 factorial into 2 factorial. This is nothing but 6 into 7 by 1 into 2. Now you can write this as 3 into 7, 21. That is the definition for NCR. We can write like this also. These both means the same thing, NCR. Let us see some properties of binomial expansion. First one, if you consider the expansion x plus a whole power n, it runs from 0 to n, NCR, x power n minus r into a power r. Since r runs from 0 to n, we can observe that number of terms will be n plus 1. Number of terms is n plus 1. For example, number of terms in x plus 1 whole power 20. Number of terms in the expansion will be 21. N plus 1 means 21 terms will be there. I think it is very clear for you. Next note point. Sum of the indices of x and a in each term. You can observe In each term, sum of the indices means n minus r plus r will be n. Sum of the indices of x and a in each term will be n. This is also most important observation. The sum of the indices of x and a in each term is n. Next note point, NCR is nothing but n factorial by n minus r factorial into r factorial. We know this. We can write this as NC n minus r also. For all r runs from 0 to n. I think it is very clear for you. That means, for example, if you see 7c3, you can write this as 7c 7 minus 3, nothing but 7c4. Both are same. I think it is very clear for you. In general, nc naught will be equals to ncn, and moreover nc1 will be equals to nc n minus 1. nc2 will be equals to ncn minus 2, and so on. I think it is very clear for you. Next note point, let us replace a by negative a. If you replace a by negative a in the expansion x plus a whole power n, we get x minus a whole power n will be equals to nc naught x power n a power 0 minus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a power 2 minus, and so on. What will be the last term? Negative 1 whole power n, because we don't know whether n is even or odd. We don't know that. So that's why I'm writing here whole power n, because if n is even, you'll get positive. If n is odd, you'll get negative, like that. ncn minus 1 whole power n, ncn x power 0 a power n, that will be the last term. I think it is very clear for you. How to write in summation? X minus a whole power n can be written as r runs from 0 to n, sum of negative 1 whole power r. Based on r, we will get either positive or negative sign. ncr x power n minus r into a power r. This will be in summation. I think it is very clear for you. We can observe that terms in x minus a whole power n alternatively gets positive and negative sign according as n is even or odd. I think it is very clear for you. According to that, last term will get either positive or negative sign. If n is even, clearly you can see it gets positive sign. Whenever n is odd, it gets negative sign. I think it is very clear for you. Next note point, let x equals to 1 and a equals to x in the expansion of x plus a whole power n. We get 1 plus x whole power n will be equals to nc naught plus nc1 x plus nc2 x square plus and so on plus ncr x power r. plus and so on plus ncn x power n. In summation 1 plus x whole power n will be sigma r runs from 0 to n ncr x power r. That will be in summation notation. I think it is very clear for you. Next note point. What will be the expansion of 1 plus x whole power n? We have seen that here. Then what will be the expansion of 1 minus x whole power n? We will get nc naught minus nc1x plus nc2x square minus nc3x cube plus and so on. Last term, it will be negative 1 whole power n ncn x power n. We will get here positive or negative accordingly whether n is even or odd. I think it is very clear for you. What will be the expansion in summation notation? 1 minus x whole power n is sigma r runs from 0 to n negative 1 whole power r ncr x power r. That will be in summation notation. I think it is very clear for you. What will be the coefficient of x power r? Coefficient of x power r in the expansion 1 plus x whole power n is, you can see here, what will be the coefficient of x square? It will be nc2. What will be the coefficient of x cube here? It will be nc3. What will be the coefficient of x power r? It will be ncr. So clearly it is ncr. Here you can see the expansion of 1 plus x whole power n. It will be here. So what will be the coefficient of x power r? It is ncr. If you want to identify coefficient of x power 4, then it will be nc4. We find the value of nc4 whenever he's giving the value of n. I think it is very clear for you.